Now here is a question given to us. An object is projected with a velocity u at an angle theta to the horizontal. Now we just clears two walls at equal height b and at a distance b apart. So we need to show that 2u cos theta multiplied by the square root of u squared sine squared theta minus 2bg is equal to 3bg. Now we need to draw this expression. So let us say you got this as a horizontal platform. I think I need to redraw that. So let us say this is what you got. Now let's say this is the ball. You got the ball at this position. And let us say that these are the two walls. This is going to be the first. And let us say this is the second. So I'm going to take it a little bit closer now. Now this has a height of b. Now the distance between this wall and the other is a b. Now let us say that the distance between this wall and the ball, let us say that is a b. So that is going to be a b. Now we know that this ball was projected with an initial velocity. So obviously stuff is going to move with a parabolic pathway. So that is going to move in this direction. Now we obviously know that there must be some tangential velocity. So I'm going to write that as a u. That is the initial velocity with which the ball was tossed into the air. Now if you got a tangential velocity or an angular form of the velocity, which of course must be inclined at an angle theta to the horizontal, and there must be the horizontal component, which here I'm going to write it as a ux. This is going to be the horizontal component. Now this will serve as the vertical component for the velocity. Now from here we know that uy, that must be equal to u sine theta. Now also we know that ux, that should be equal to u cos theta. From the resolution of vectors into their components, we should be able to tell that. So you just need to hold these ones at the back. Now the next thing I'm going to do is I'm just going to try to work some stuff from this equation or formula which was given to us. So here what we got is this. We got 2u cos theta multiplied by the square root of u squared sine squared theta minus a 2bg. That is equal to 3bg. Now, the first thing we're going to do is I'm actually going to square both sides. So, well, I think what I'm going to do here is I'm going to take these out for now. Now, if I square both sides, this is going to be 2u cos theta with the square root of this stuff. So that is u squared sine squared theta minus a 2bg. And this is equal to 3bg. So we need to square both sides. I'm going to take this one out now. So this will be squared and this is going to be squared also. So if we did that, we need to apply the square to each term which is within this bracket. So that is going to be 2 squared, giving you a 4. Now u squared, that is going to be the second stuff formed there. And we're going to have a cosine squared theta. And on this side, we're going to have a u squared sine squared theta minus a 2bg. Now this is because this square is going to take out this square root sign as it distributes on this bracket. And on these other side, we're going to have a 9b squared g squared. So that is what we're going to have. Now next up, I could take this to this side. Now, if I did that, we're going to be left with u squared sine squared theta minus 2bg. That is going to be equal to 9b squared g squared divided by 4 u squared cos squared theta. So that is what we're going to have there. Now I could take this to the other side. So I'm going to wipe these out. Now I'm going to take these out also. Hopefully you have written it out somewhere. So this is going to be u squared, and we got is u squared sine theta. And on this side we're going to have a 2bg. So this will be plus 9b squared g squared divided by 4u squared cos squared theta. So this is what you're going to have. So you need to hold these at the back because later on we're going to use it. Specifically this stuff. We're going to make use of this later on. So just hold at the back this stuff. 2bg. Okay, so I think I'm gonna write it out somewhere. So let us say we got that here. That will be u squared squared theta is equal to 2bg plus whatever should be there. Of course, we know we're going to find this later on, so I don't really need to worry about that. Now, the next thing is that drawing or that diagram. We're going to go back to it. So we know this is the ball, and these are the two walls, which in this case, their heights are given as a b, and their distance from each other, those are also represented as a b. And we designated that the distance between the ball and the first wall is a b. So the distance between the ball and the second wall, that is going to be a 2b. So from here until you reach this point, this is going to be equal to 2b. Now we know this stuff was projected, and obviously it's going to go in this direction. So there is a tangential velocity, which is written as a u. This is going to be the angle of projection. So we got this to be ux, that is the velocity in the horizontal axis, and this would serve as the velocity in the vertical axis, which is uy. Now you need to hold something at the back. What you need to know is that first, we got the vertical distance or displacement of this ball as it comes to the first wall. As it rises, there is actually going to be the formula which you would need to use in order to find out what will be the vertical displacement against gravity. So how are you going to find it? What is going to be the formula? Now we know that typically should be y, and y is equal to, or I should rather start with the beginning part of it, which is s, and that must be equal to ut minus 1 over 2. So this is 1 over 2 gt squared. Now this is pretty reasonable because we know that this is going to be the distance or the displacement covered. Now if we talk about the vertical distance from this place to whichever point, which is basically going to be the height of the wall, from the ground level to the height of the wall, that is going to be a vertical distance. And so that is in the y-axis. So that is what you're going to have. Now, if we want to do that, we need to use the vertical component for the velocity, which we said that should be u sine theta in it. So in this case, we're going to have a u sine theta, and that will be minus 1 over 2 gt squared. Well, so I needed to add this t. So that is going to be there. And so that is what you're going to have. Now we also know that this stuff, which is a vertical distance or displacement, that is the same thing as the height of the building, which is a b. So in that case, I'm going to write it as a b. B is going to be equal to u sine theta multiplied by t. That will be minus 1 over 2 gt squared. So that is what you have for the vertical displacement. So you just need to hold that at the back. That is going to be useful as we go on. Now let us go on to the horizontal displacement of this ball. We know that velocity generally must be equal to displacement divided by time. Now this velocity is going to be the initial velocity in the horizontal perspective. So that should be ux. Now we know ux is going to be u cos theta. So I'm going to rewrite it here. This is u cos theta. And this is going to stand for the displacement. So let us say the displacement from the position of this ball to the first wall is b. So that will be b divided by t1. Now t1 stands for the time taken to reach this wall. That is the first feet of the wall. So if we want to make t1 the subject of the formula, that is, well, rather making b as a subject, b is going to be equal to u cos theta, well, that is cos theta t multiplied by t1. So that is basically what you're going to have. Now what if we wanted to make t1 the subject? If I wanted to make t1 the subject, t1, that is going to be equal to b divided by u cosine theta. So this is actually going to be very useful as we continue in this derivation. So just remember that. Now what if I wanted to find the velocity involved if you were to reach the second wall? So that will be from this ball to the second wall. The displacement there should be 2b. So that is going to be u cos theta is equal to displacement, which is 2b in this case, and that will be divided by t2. So this stands for the time taken in order to reach the second wall. So I could also make t2 the subject. So at this point, I think I'm going to take this one out. I'm going to take these out. So in this case, we got t2. Well, I'm just going to write t1 first. So t1 is equal to u, well, that is equal to b divided by u cos theta. T2 is going to be equal to 2b divided by u cos theta. So that is what we're going to have. So I'm going to take these ones out. Now, we're basically going to plug those relations which we have for time in the first case in this place as well as the second case. So first, let us find out what is going to be the vertical displacement if you have the stuff reaching just the first wall. So let us say that this is the first wall, wall 1. So that is going to be equal to b, and b will be equal to u sine theta. So that is going to be, I think I'm just going to shift it a little bit. So let's say the first wall, that is the displacement which is involved if the ball is going to hit the first wall or just over the first wall. We're going to use this one. So that will be b, and b is equal to u sine theta multiplied by t. Now t in this case is b divided by u cos theta. And that will be minus 1 over 2. We got a g. Now this stuff is going to be b divided by u cos theta. And that will be squared. From here we can see that this stuff is going to cancel this. So that should leave us with, well, so I'm going to write this. So b is going to be equal to b. Now you got sine theta. divided by cos theta. And on this side we have a half. This is going to be g. So we need to take the squared and distribute it on every term which is within the bracket. So that will be b squared. And on this side we're going to have a u squared cos squared theta. So that is what we have for the first one. Now secondly, we're going to use T2. That is the time that is taken to reach the second wall, which we said that should be T2 equal to 2b divided by u cos theta. Always feel free to rewind the video and try to go back to any point which you do not really understand so well. So let us try to find that one. That will be b. So b in that case will be equal to u sine theta, and that will be multiplied by 2b divided by u cos theta. This will be minus 1 over 2, and we got a g. This will be 2b divided by u cos, so that will be u cos theta all squared. So if I want to rewrite this, so I think I'm going to take this one out for now. So I think I'm going to wipe these also out. Just need to remember that u squared sine squared theta was equal to 2bg plus something. Okay? So if I want to rewrite this, b is going to be, well, that is the displacement in terms of b. So b is going to be equal to u sine theta, and here we're going to have a 2b, and that will be divided by u cos theta. That will be minus 1 over 2. This is going to be a g. And here we're going to have a 4b squared, because we got a 2 multiplied by everything which is on top there, which basically is going to give us a 4b squared. And then that will be divided by u squared. So this will be u squared cos squared theta. So that is what you're going to have for the second case. That will be the displacement involved if you were actually required to have that ball pass the second wall. So this stands for the second wall, and this would stand for the first wall. Now we're not yet done. We're going to take this stuff, that is the displacement in case of the second wall, and we're going to take this one and subtract it from this one. So that is equation A subtracted from equation B, or equation B minus equation A. So let us see how that's going to work. So that will be B minus A. Now if you got B minus a B, that is going to give you 0. Now here we obviously know that this stuff is going to cancel these out. So that is just going to leave us with 2b multiplied by sine theta divided by cosine theta. Now if you got sine theta divided by cosine theta, that should give you tan theta. So typically what we got here is a 2b. So this is typically a 2b multiplied by sine theta divided by cosine theta. And so this is almost the same thing. We got 2 of it in the equation B, whilst we got just 1 of it in the equation A. So that should leave us with just 1 of it. B sine theta divided by cosine theta. Now you need to know that this, if you got sine theta divided by cosine theta, that will be tan theta. So this is 2b tan theta minus b tan theta, which is basically going to give us a b tan theta, because in that case we got 2 of it subtracting 1 of it. So that will be b tan theta. So here we got b tan theta. Now on this side we got 2 canceling into this. So this should be a 2gb squared divided by whatever, which we have there. This is a minus, so I need to place a minus there. And this will be minus because we need to have a minus here. So that will be minus this stuff, which is actually going to be a GB squared divided by 2U squared. Well, so this should be square theta. I just need to, I think I just need to write this out. So this is going to be U squared cosine squared theta. Now, if we want to take this and add it to this, there is going to be a whole lot of change. So how can that work? So let us see how it's going to work. First, we know this is going to be 2GB squared divided by U squared cos 2 squared. Well, that is cos squared theta. Now this is going to be plus GB squared divided by 2U squared. So this is going to be 2U squared cos squared theta. Now if we work this is actually going to give us a 3GB squared divided by 2U squared and everything that follows. So in that case, I'm going to take these out. And I'm going to write it here. That must be a minus. So this is a minus 3GB squared divided by 2U squared cosine squared theta. So this is 2 U squared cosine squared theta. Now, in this case, we have a 0. 0 is equal to b tan theta minus 3GB squared divided by 2U squared cosine squared theta. So the first thing I'm going to do is take this stuff to this side. So that is going to be 3GB squared divided by 2U squared cosine squared theta. That will be equal to b tan theta. Now the next thing I'm going to do here is to take out one of the b's because we got a b here. And there is also another one there. So from here we should have a tan theta be equal to 3bg. That will be divided by 2u squared cosine squared theta. So that is what we got. Now I'm going to take this to this other side. So I need to take these out. So that will leave us with 2u squared cosine squared theta. Here we're going to have a tan theta. That is equal to a 3bg. So that is what we got. Now what is going to be the next thing that we need to do? So we need to change this stuff. So first we got 2u squared cosine squared theta. This is going to be sine theta divided by cosine theta. Now cosine theta is going to cancel one of it here. So that is what we're going to have there. And so we're going to have this. So I need to rewrite this. So here we're going to have a 2u squared cos theta. And you got a sine theta. This is going to be equal to 3bg. So going forward, we're going to have this. I'm going to write it this way. So that will be 2u squared. Well, I'm just going to change it to, let's start with u sine theta. We got u cosine theta that is equal to 3bg. Now I'm going to take this with this. That is 2u cosine theta, and I'm going to divide through by that. So that will leave me with u sine theta on the left hand side, and here I'm going to have a 3bg. That will be divided by 2u cosine theta. That is what I'm going to have there. Now if I want to square both sides, this is going to give me a new stuff altogether. So let us square both sides. So if we did that, on this side we're going to have a u sine theta all squared. And on the other side, we're going to have a 3bg. That will be divided by 2u cosine theta. So this is also going to be squared. Now this stuff is going to give us a u squared sine squared theta. And on this side, we're going to have a 9bg. That will be divided by, so this is going to be 4u squared cos, well, so this is 4u squared cos squared theta. So that is what we're going to have. Now we remember that we need to have something more than this. That is, this is not enough. From what we said, there must be a 2bg there in it. So I'm going to add that. So ideally, we need to have a u squared sine squared theta. That will be equal to 2bg plus what we got here, which is a 9bg divided by 4u squared cos squared theta. Now next thing I'm going to do is take this to the other side. So this is going to be u squared sine squared theta minus 2bg. And this is going to be 9bg. This will be divided by 4u squared cos squared theta. So that is what we got there. Now the next thing I'm going to do, well, so I really made a mistake here. I needed to square everything here. So that should not only be a 9, but that will be a 9b, b squared, g squared. So this should be a square root, and here also. So that is what we got there. Now, the next thing I'm going to do is find the square root of both sides. So we need to take the square root of both sides. So in order to do that, this stuff is going to have a square root sign, which is going to be u squared sine squared theta minus 2bg. And on this side, we're going to have a, this is a square root sign for 9b squared g squared. This will be divided by 4u squared cos squared theta. So on this side, we're just going to have this maintained. So that will be u squared sine squared theta minus 2bg. And on this side, we're going to take the square root of this stuff. Now the square root of this is basically a 3. The square root of a b squared, that is going to be a b. And the square root of a g squared, that will be a g. This will be divided by square root of 4, which is going to be a 2. The square root of a u squared, that is a u. And if you got the square root of a cosine squared, that should be a cos theta. So this is what you got. Now next off, I'm going to multiply both sides with this stuff. So if I multiply both sides with 2u cos theta, Here I'm going to have that cancel out here. And this stuff is going to move to the other side. So that would now give us a new form, which is going to be the 2u cos theta. That is going to be equal to u squared sine squared theta minus 2bg. This is going to be equal to 3bg. So this is basically is what is going to be left. Now from other texts, you might see that you are required to show that the left hand side of this equation is equal to bg and not 3bg. Now, mathematically, that question is going to be wrong. You cannot actually show that this is equal to this, but this is equal to this. So this is actually the correct form of the question. There should be a 3 in that position. So in that way, that is actually going to work, but not for bg only. That cannot work for that. So therefore, the answer to the question is this. We have derived it. So this question follows up from the first question we just solved or derived, where we are asked to find out what will be the values for b if we got the initial velocity u to be 50 meter per second and at the angle of 60 degrees. So the first thing we need to do, bring out our parameters. U is equal to 50 meter per second. And we got theta. So theta is equal to 60 degrees. So we need to find what g is. So this is what we got. We got 2u cos theta. That is multiplied by the square root of u squared sine squared theta minus 2bg. This is equal to bg. This is the formula that is provided for us to use. Now in order to get it, we first of all need to square both sides. So that is going to be, I'm going to rewrite it here. So that will be 2u cos theta. Now that will be u squared sine squared theta minus a 2bg. And on this side, this is going to be a bg. This should be squared. This is also going to be squared. Now as usual, we need to take this squared and distribute it as a power on each term within the bracket. So first we're going to take 2 squared. That should give us a 4. Next up, we're going to take a u. That will be squared. So that is a u squared. This is going to be cos squared theta. Now, if you got a square root, which is raised to the power of a 2, that 2 is going to cancel out the square root sign. So we should be left with u squared sine squared theta minus a 2bg. And on this side, we're going to have a b squared g squared. So that is what we have. Now remember, we need to find out what g is. So the next thing I'm going to do is to try to isolate b. Well, what does that say? We need to find a b in it. So that is exactly where I'm driving at. We need to make b get to be isolated as much as possible. So next thing I'm going to do is take this stuff and divide both sides with it. So that is going to cause it to leave this left hand side. So what we're going to have on the left hand side would just be u squared of sine squared theta minus a 2bg. This will be equal to b squared g squared divided by 4 u squared cos squared theta. Now this is also going to come this side. Now instead of doing that, I might well just bring it to this other side. but because I really do want you to understand it, so I'm just going to take everything to the right hand side typically. So this is going to be equal to b squared g squared. That will be divided by 4 u squared cosine square theta. This will be plus 2bg. This is going to be minus u squared sine square theta. So we need to find what b is. Now we know that g is equal to 9.8 and u is 50. So we just need to plug in those values there and see what that is going to give. So this is a quadratic equation. So we have b squared, and here this is going to be 9.8 squared. This will be divided by 4 u squared, that is going to be 50 squared. You got cosine theta squared, so I think I need to rewrite that. So this is going to be multiplied by 50, which is squared, and this is going to be cos 60, that is also squared. This will be plus 2bg, so that is 9.8. We're going to have a minus u squared, which is a 50 squared. In here we have a sine 60, that is also going to be squared. So let's see what that is going to give. So this is going to be b squared, and that will be multiplied by 9.8 squared, which is going to give us 96.04 squared. This will be divided by 4, multiplied by 2500. That will be multiplied by cos 60 squared. Now cos 60, that is a 0.5, so we need to square this. Now here we're going to have a 2 multiplied by 9.8, so that is going to give us a 19.6, so that would be b. Now this is 50 squared, which is a minus 2500, so that is going to be 2500. This will be multiplied by sine 60 squared. So sine 60, that is 0.866. And so this stuff is already going to be squared. Oh, so I need to write it better now. So that is what we got there. So we actually need to square that later on. So I think I'm going to take this away. Yep, we don't really need to square this. So this is going to be a 0. Now on the side that is below here, that is going to give us a 2500, because this is going to be a 0.5 in 2 places. So that will be 4 multiplied by 0.5. That will give us a 2. Now you're going to have a 2 multiplied by another 0.5. So that is going to give you a 1. So you're going to have a 1 multiplied by 2500. Therefore, what we're going to have here is b squared 96.04. This will be divided by 2500. And then on this side, we're going to have a 19.6b. And on this side, we're going to have a minus 1874.9. Now from here, we're going to have a real quadratic expression that will be 0.038b squared. This will be plus 19.6b, and that will be minus 1874.9. So we need to find b. If you plugged in this expression into your calculator, you're going to find that b, that is one value of b, I'm going to write that as b1. That will be equal to minus 598. So that is 598 minus 26 meter. So this will be one value for the height, which is actually what we're finding. And another value you're going to have is b, that is going to be equal to 82.47. So that will be 82.47 meter. Now this is going to work. This will be the real answer to the question, because you cannot have distance being in the negative. So this doesn't work, but this is going to work. So this will be the correct answer. So in that case, we got B. B is equal to, that is equal to 82 rather, 0.47.